Oh, yum. That's a great idea. Yeah.
Oh, hey, everyone. Here in the United States, it's almost time for Thanksgiving. That's a day when you get your friends and family together to eat a big, tasty meal. So Squeaks and I are planning dinner and making a shopping list. So far, we have mashed potatoes, cranberry sauce, turkey, green bean casserole. I can't wait. And we're going to have some of our favorite foods. A huge block of cheese for Squeaks, of course, and a delicious pumpkin pie for me. Oh, wow, that's a great idea, Squeaks. Squeaks suggested we make some of our friends' favorite food, too. That'll make our dinner really special. Okay, let's see who we have on our guest list. First up is Sam the Bat.
Oh, hi everyone. Sorry about that. I got to the fort pretty early this morning, so I'm still a little sleepy.
Mr. Brown, hey, Mr. Brown.
Oh, hey, good morning, Sam. You're here awfully early.
Yeah, it's because I've made an amazing discovery, a space rock. Check it out.
Whoa, where did you find this?
Well, I was up late last night looking at the stars, per usual, but this time there were lots of shooting stars, bright lights streaking across the sky. And then, when I went outside this morning, I found this super weird rock on the ground. It didn't look anything like the rocks around it, and it looked so cool and different, I had to bring it in for you to see. I think it's from space.
Let me see. You know, Sam, I think this could be from space. Well, everyone, I think it's time to do some meteorite tests. When we look up at the night sky, we mostly just see stars. But if you had a really powerful telescope, you could also see that space is full of rocks just zooming around. These rocks come in all shapes and sizes, and sometimes they get into the layer of air all around Earth called the atmosphere. And when they do, they fall really fast towards the ground. In fact, the rocks fall so fast that they start to get really hot as they move through the atmosphere, and then they burn up. And when they do, they can leave a bright streak of light across the sky. Sound familiar, Sam?
That sounds like the shooting stars I saw.
Exactly. When those rocks are burning up in our atmosphere, we call them shooting stars or meteors. I mean, they aren't really stars. We just call them that because they're bright lights in the night sky, like real stars are. Most of the time, those meteors burn up nearly all the way, so there's almost no rock left. But sometimes pieces of rock make it all the way to Earth's surface. If they hit the ground, we call them meteorites. Most meteorites are small, usually no bigger than my hand, and they're made out of bits of crystal or iron. Crystals aren't rocks, but they look a lot like them. They're hard, usually have lots of straight lines, and are sometimes clear or a bit see-through in places. A lot like rock candy. And iron is a really hard, shiny metal.
Okay, so you're saying that this could be a meteorite.
It could be, but let's run some tests to find out. There are a lot of different rocks here on Earth, so there are some tests you can do right at home to see if you might have found a real meteorite. The tests have to do with the properties of the rock. Those are things you can observe or notice about it, like its color and shape. And you've already finished the first test, Sam.
What do you mean?
Well, the first test is to see whether your rock is like other rocks nearby. Does it match the other rocks in the area, or does it stand out? So Sam, compared to other nearby rocks, was this one a different color or texture or shape?
None of the other rocks nearby looked or felt like it. The other rocks were all gray or red, and they were all round.
All right, let's move on to the second test. Color. Meteorites get to Earth after burning through the atmosphere. And when they burn, they normally change colors. It's just like how wood or paper turns black when you burn it in a campfire. So meteorites normally have a layer of black or dark brown color on the outside.
My rock is really dark brown, maybe because it was burning in space.
All right, so far so good. But let's look at shape next. Meteorites usually aren't perfect circles or squares. Instead, they have irregular or unusual shapes. Like they might look really lumpy. But an important thing is they also feel smooth and don't have any holes in them.
Well, this rock is shaped like a meteorite, and it doesn't have any holes in it, but it's not that smooth.
All right, Let's take a look at the next test then. This is a test to see how dense the rock is. We say an object is really dense when it's pretty small, but also really heavy for its size. If you pick up a small object and it's way heavier than it looks, that's probably a good sign that it's dense. Meteorites are really dense, so they have a lot of stuff packed into a small space. This makes them a lot heavier than Earth rocks that are the same size. I actually brought some rocks in from the garden earlier this morning so I could learn more about them, so we can compare how heavy they feel.
So, how heavy does it feel compared to my rock?
You know, your rock does feel pretty heavy. I think it's pretty dense.
Whoa! Does that mean it's a meteorite?
Let's do one last test just to be sure. We're gonna test if your rock is magnetic. Do you remember what meteorites are made of, Sam?
Totally. They're made of crystals or metal.
That's right. Most meteorites have the metal iron in them, and iron sticks to magnets. When something sticks to a magnet, we call it magnetic. So if this rock is a meteorite, then the iron in it should make this magnet stick to the rock.
Let's try it.
Look at that!
Whoa!
It's magnetic! So let's see what we learned. This is an unusual rock, and it's the right color to be a meteorite. It also has a good irregular shape like a meteorite. It is a little rough, but it also doesn't have holes. It's also pretty dense and is magnetic. What do you think, Sam?
That sounds like a meteorite to me.
You know, I think you're right. Even if it's not super smooth, it checks all our other boxes. So wow, congrats, Sam. You found a space rock.
Whoa! Thanks, Mr. Brown. I had a lot of fun learning about my rock, too. Meteorite testing with you is really cool, and I learned a lot. Actually, now I want to go see if there are any other meteorites outside. I'll catch you later.
I'm glad you enjoyed it. Bye, Sam.
Bye.
Sam the Bat loves space, and I happen to know that he loves spaghetti. So what if we made him a spaghetti and meatball solar system with different meatballs for all the planets? Right. Sam is a bat, and they love eating bugs, so I'll need to make mosquito meatballs. I'll need to find a recipe for that. Okay, next up is our neighbor, Mr. Brown.
Oh, hi everyone. Squeaks is supposed to meet me here in the lab, but he's not here yet. I wonder what's taking him so long. I'm super excited to see him because he promised he'd show me his new magnet. Oh, there you are, Squeaks. Is everything okay? Oh, I see. Squeaks was trying out his new magnet by the river, and the path there is really long and windy, so it took him a while to find his way back to the fort. The river is directly south of here. If only you had had a compass, then you could have taken a shortcut. A compass, it's a tool that can tell you what direction you're going. And if you know what direction you're going, you can find your way around without getting lost. People have been using compasses for thousands of years to explore the world. They can be big or small, fancy or plain, but they have an important thing in common. They have some kind of arrow or needle that points north. So if we had a compass right now, its needle would point this way, because that's north. In fact, we can use your magnet to make your own compass right here at the fort. What do you say, Squeaks? All right, let's do it. You can make a compass too. Just make sure you get a grown-up to help you. To make a compass, you'll need a sewing needle, a piece of aluminum foil, and a clear container of water with a flat bottom. Oh yes, and a magnet. Thanks, Squeaks. This is definitely where you'll want help from a grown-up. First, carefully pick up the sewing needle and hold it by the end that has the hole in it. Now, drag the magnet along the needle slowly from the end with the hole to the pointy end like this. You'll need to do this about 15 or 20 times, and always make sure you're doing it the same way from the hole end to the needle point. Next, we'll need to fold our foil into a little boat of sorts, and then poke the needle through it. Again, make sure a grown-up helps you with this. Trust me, poking your finger with the needle hurts. Now we're ready to finish our compass. All we have to do is gently float the foil on the water in our bowl, wait a second, and look, the needle turned and it is now pointing north. We did it. Good question, Squeaks. But before I explain what happened in this experiment, let me explain how compasses work in general. The reason why a compass points north is really cool. It's because the pointy part inside is a magnet, and magnets have two ends called poles. One end of the magnet is called the North Pole, and the other is called the South Pole, no matter which direction they're facing. And opposite poles of two different magnets attract. That means they pull on each other. Meanwhile, similar poles repel each other. Repel means push away. Now here's the really awesome part. Our planet Earth is basically one huge magnet, so it also has magnetic poles. That means the Earth's poles act the same way that a magnet's poles do. They attract and repel the poles of other magnets. And they just so happen to line up pretty well with the parts of the planet we call the North and South Pole. You've got it! The Earth's magnetic poles pull and push a compass needle's magnetic poles, and that's what causes the compass to point north. So why do you think our sewing needle pointed north? That's right! I said the needle of a compass is a magnet, so... Yeah, that's it! Our sewing needle became a magnet. That first step we did, where we rubbed the needle with your magnet, actually magnetized the sewing needle. In other words, it turned it into a magnet. The pointy end became the North Pole of a magnet, and the other end became the South Pole. You know, Squeaks, you're absolutely right. It seems like the North Pole of the Earth should repel the North Pole of our compass needle. But here's the weird thing. The Earth's north magnetic pole is actually in the south, and its south magnetic pole is in the north. So the Earth's south magnetic pole is pulling the North Pole of our needle to the north, and the Earth's north magnetic pole is pulling the South Pole of our needle to the south. Which is weird and confusing, I know, but hey, I didn't name these things. Exactly, Squeaks. Since the Earth's magnetic poles are always pulling on the poles of other magnets, all we had to do to get our magnetized needle to point north was let it freely spin about in response to those forces, which is what the foil and water were for. Cool, huh? Oh, whoa, look at the time. We told Jessi we'd meet her in the garden to help pull weeds, so we better get going. And we'll look into getting you a compass that's a bit easier to carry around than this ball. That way, you can make your way to and from the river a little quicker next time.
Mr. Brown loves camping and roasting things over the campfire, like hot dogs and marshmallows. So even though they aren't really traditional Thanksgiving foods, let's make Mr. Brown a whole bunch of hot dogs. And we can have a fire in the backyard after dinner and make s'mores for dessert. What do you think? All right, next up are Bill and Webb, the duck twins.
Whoa! What's going on? What's all this quacking about?
Well, we were in Sam the Bat's observatory, and there was a button really high up on the wall that we really wanted to push to see what it would do.
Yeah, and neither of us could reach it. But I told Bill about something called engineering that could help us.
Wow, that's a great idea. Engineering is how people develop solutions to problems. First, engineers identify a situation they want to change, and then they design and test solutions to the problem.
Yeah, it sounded cool.
So you identified the problem, you couldn't reach the button, and you decided to approach the problem using engineering. What happened next?
Well, we each designed a high-up button pusher to help us try to reach the button.
But I think mine is better than
Webb's.
Bill's.
All right, settle down, you two. I bet both of you came up with some great designs. Why don't you show me what you made?
I have my design right here. You can see that I nailed several long pieces of lumber together. I can reach some high buttons.
Wow, Bill. I can see that your design is very strong and stiff. It would be great for reaching things that are far away like that button, but it also looks very heavy. I can imagine it might be hard for you to lift this one up.
Yeah, it was a little hard to handle when I was testing it in the observatory.
Well, look at mine. It's nice and lightweight. Just tape and a stick at the end.
Webb, yours does look very light, which would make it very easy for almost anyone to use. But it's a little bit floppy, don't you think?
It was very easy to lift up, but you're right. it was kind of hard to control.
Well, you know, the best part about engineering is that there can be more than one way to solve the same problem. You both came up with solutions to the problem, and both of them had strengths and weaknesses when you tested them out. Let's think about what those were. Bill, yours was strong but hard to use. Webb, yours was easy to use but super flimsy. But that's okay, because finding a really good solution to a problem sometimes takes a few tries. Even engineers have to test their designs to see what's working and what's not working and make them better. Orville and Wilbur Wright were two brothers who made the first airplane to fly in the sky. But before that, they tested many designs. First, they made gliders that could only glide through the air instead of flying. Then they added engines so those gliders could stay up in the sky, and they had an airplane. Maybe we can take a little bit from each of your designs and make an even better high-up button pusher.
What if we use the tape from mine to tape small, lightweight pieces of wood together?
Yeah, then it would be strong like mine, but lightweight like Webb's design.
Great ideas, you two. Let's build a new design that combines a little bit from each and see how it does.
Ta-da!
Wow! Look at this great design that you worked together to make.
Yeah, it's still made of strong wood, just smaller pieces.
The small pieces of wood help make it lightweight so anyone can lift it up.
Great work, you two, using your engineering and teamwork skills to create an excellent solution to a problem. Let's head to the observatory to test it out.
Yeah!
If there's one thing I know about Bill and Webb, aside from that they love to argue, is that they have two favorite foods. The first one is gummy worms, and the second one is earthworms. So I'll make a big bowl of each. Oh, good thinking. I better get them each their own bowls or else they'll spend all of dinner fighting over them. Next is Dino the cuckoo bird. Hey there! Squeaks and I are here with our friend Dino, and our library just got a new book that has pictures of all the different kinds of dinosaurs that used to live on Earth. And it tells a little about them too.
Like what they ate. This page says that some dinosaurs like Stegosaurus and Triceratops ate plants. So I was thinking that they must have been friends who hit up the salad bar together.
Dino.
But they definitely weren't friends with the meat eaters like Allosaurus and T-Rex. I bet they had amazing dinosaur races as they ran to catch the best food.
Dino.
Yes, Jessi. What do you think?
I think that it's fun to imagine what these animals might have done if they'd met. And I also think we need to remember that Stegosaurus and Triceratops weren't around at the same time.
Wait, what?
I'm sorry, Dino, but the same is true for Allosaurus and T-Rex. These dinosaurs lived in different times from one another.
I don't get it. They all lived back at the time of the dinosaurs, right?
Yep, you're right about that. But the time of the dinosaurs was a very long time. It lasted millions of years. So all dinosaurs didn't live at the same time. Oh, good point, Squeaks. We built a pretend time machine to imagine what it would be like to travel back in time and see living things from the past. But to see all of these dinosaurs, we would have to make more than one trip.
So if we took your time machine back to the time of the dinosaurs, we'd actually have to go to lots of different times?
Exactly! Scientists divide dinosaur time into 3 parts, called periods. There's the Triassic period, which started over 200 million years ago. Some small dinosaurs like Eoraptor lived then. Next came the Jurassic period. Allosaurus and Stegosaurus were alive during this period. The Jurassic period lasted over 50 million years. It was after that that dinosaurs like Triceratops and T-Rex came along, in a time called the Cretaceous period. Oh, you're right, Squeaks. It can be pretty hard to think about long periods of time like that. But I have an idea we can use to show how long ago dinosaurs lived. We can use our bodies as a model. We use models to help us understand or explain something in the world around us. By using our bodies as a model of dinosaur time, we can get a better picture of just how long ago those different periods were. It won't be perfect, but it will be a way for us to think about things that happened a long time ago. Now, let's say the bottom of your shoe choose is the bottom of our model, when the very first dinosaurs appeared. That's the beginning of the Triassic period, about 245 million years ago.
Okay.
Stegosaurus and Allosaurus didn't show up until the Jurassic period, about 50 million years later. That means that these dinosaurs would have lived in the time that starts somewhere below your knee and ends somewhere around your hips. That distance on your body represents about 56 million years.
Then it was T-Rex time.
The Cretaceous period was about 74 million years long. That means if it starts at your hips, it should end at about your chest. And the time of the dinosaurs ended about 65 million years ago. So everything from your chest to the top of your head represents the last 65 million years. Ooh, good question, Squeaks. Humans and their ancestors have only been on Earth for about 6 million years. So in our model, that would be only the last couple centimeters of your body, maybe from the top of your forehead up.
Wow, so people haven't been around for very long at all.
No, life on Earth was around a long time, even before there were dinosaurs. And I mean a long time. And over that time, the way Earth looked and the plants, animals, and other kinds of life that lived here changed a lot. Some of these changes happened very fast, like volcanic eruptions, but others happened very slowly. So slow that we wouldn't have noticed they were happening, even if people had been around. Ooh, great question. Squeaks wants to know how we know plants and animals lived during different times if no one was there to see them.
I think I know this one. Is it because of fossils?
Good job, Dino. We found fossils. Bones, footprints, and other things left behind by ancient animals, plants, and other kinds of life. We use these fossils as clues to try and figure out how long ago they might have lived.
How?
Well, one way we can tell which fossils are older and which are newer is by how deeply they're buried. Think about paper in a recycling bin. The paper that you put into the empty bin last week is on the very bottom of the can, and it gets buried by the paper you throw in later. The very top layer of paper in the recycling bin is the paper you put in there today, this morning, or even a few minutes ago.
Oh, I see. So the fossils that are deep in the ground like Stegosaurus are older than the ones closer to the top of the ground like the T-Rex.
That's right. T-Rex is pretty young.
Well, in dinosaur years anyway.
Yes. Now let's see what else we can learn about in this new book. This is an easy one. Dino loves dinosaurs more than anything else in the world. So we'll make him some of my famous birdseed cookies and cut them into the shapes of dinosaurs. Oh, don't worry, Squeaks. I'll make some chocolate chip cookies too. And last is our friend Grady the Tardigrade. Hi everyone, I was just working in the fort's greenhouse, and Squeaks, I have some good news. The plants are doing really well. Pretty soon, we should be able to make a yummy salad out of the vegetables we're growing. Gardening can be a bit dirty, but it's worth it. As I was cleaning up, I started thinking that maybe we should take a closer look at the dirt our plants grow in. What we often think of as just dirt, especially when we have to clean up, is really interesting. Scientists would actually call the dirt in our gardens soil, and it's home to an incredible number of living things. Oh, that's right, Squeaks. We can see a few animals like earthworms when we're digging in the garden, and they're super important. They help the plants in our garden to get the air and food they need to grow. But there are other living things in the soil that we can't see with our eyes. We need tools, like this microscope, to see them. Let's give it a try.
Howdy up there. I had a feeling I was being watched.
Oh, hi! We didn't mean to startle you. I'm Jessi, and this is Squeaks. We're hoping to learn more about the kinds of living things in soil.
Well, you sure have come to the right place. Name's Grady. Glad to meet you. I'm what's called a tardigrade. Some people like to call my family and I water bears or moss piglets, but we're our own little group of living things. Emphasis on the little. Most of us are only 0.5 millimeter long, about the size of a period at the end of a sentence. So we tend to get overlooked a lot.
Well, I'm sure glad we didn't overlook you. Would you mind telling us a little bit about your neighborhood?
Well, It would be my pleasure. The soil I live in is a mixture of things like water, small pieces of rock, and air. It also has a lot of what we call organic matter. That's our fancy term for things that either were alive, like the remains of dead plants and animals, or are alive, like me. I'm one of billions of critters that can be found in a single spoonful of soil.
Wow, that's a lot of living things in such a small space. There are about 7 billion people, but they're living on the entire planet.
And not only are there a lot of us in the soil, there's also a lot of different kinds of living things. We call the different living things in an area, it's biodiversity. The bio part of the word means living, and the word diversity means different things. And soil has a whole heap of biodiversity. There are more different kinds of living things beneath your feet in the soil than there are above the ground.
That's amazing.
What's even more amazing is how the living things in the soil and life above the soil are connected. Take the plants in your garden, for example. They're stuck in the ground by roots, and those roots also help them slurp up things they need, like water. But they also release stuff into the soil, like sugar. Microscopic living things, called bacteria, can use this sugar to grow. And, in return, some kinds of bacteria release things that the plants need.
Well, that's a win-win.
And that's only one example. Other living things called fungi also work together with plant roots.
Fungi is a science word for the group of living things that includes mushrooms. It's kind of like how we talk about plants or animals. There are actually millions of different kinds of fungi, including the ones we see growing out of rotten logs when we hike, or the tasty mushrooms we like to eat. Just talking about fungi makes me hungry for some yummy mushroom soup.
Exactly. Though these fungi I'm talking about in the soil don't look like the ones you put on your plate. They grow in super thin strands that extend outward from a plant's roots. In fact, they kind of act like extra roots that help the plant pull things from the soil. It is kind of nice of them, isn't it? Of course, they benefit too. In return for helping out, the plant gives the fungi some of the food it makes and other useful things. It's a sweet little partnership. Though not all soil fungi and bacteria hitch themselves to roots. Some get energy by breaking down the dead plants and animals I mentioned earlier. They're what we call decomposers. You can think of decomposers as the soil version of the workers that pick up the recycling in your neighborhood. Think about what would happen if no one was ever there to pick up recycling. Whew, it would pile up. And so would dead plants and animals if decomposers weren't around.
I agree, Squeaks. That would be terrible. Decomposers sound super important.
They sure are. They also matter because lots of soil-dwelling animals eat them. So, in addition to cleaning up our neighborhood, the decomposers that live in soil are an important source of food for critters like worms and tardigrades like me. Then, after we eat them, the waste we produce acts as a fertilizer, helping plants above the soil stay healthy.
Wow, I didn't know that our garden owes so much to all the tiny things that live in the soil. Thanks, Grady.
Don't mention it. Now, if you'll excuse me, it's supper time, and I had my eye on some tasty fungi. So y'all have a nice evening.
Thanks, you too. Bye. Squeaks, how about we go ahead and put our soil back in the greenhouse, and then we can have our dinner too. Tardigrades are hardy microscopic animals that eat all kinds of microscopic stuff, like bacteria. So, I guess, add bacteria to the list, and we'll figure that one out later. Okay, Squeaks, it looks like our shopping list is ready. I can't wait to surprise our friends with all of their favorite foods, even if some seem a little weird to us. I'm sort of excited to try a mosquito meatball. Thanks for joining us today. If you'd like to keep learning and having fun with me, Squeaks, and all of our friends, make sure to hit the subscribe button, and we'll see you next time here at the fort.